For our next scenario, we want to look at how we can take advantage of renewable energy assets during island operations. So one of the key benefits that a microgrid can offer to a facility is that resiliency component, being able to operate when the grid is not available, either as part of a planned transition or an unexpected resiliency event, being able to make full use of available assets in those times to keep your lights on, your system up and running for as long as possible in those scenarios is a key value that microgrids can offer to a facility. So in this scenario, we're going to be looking at that conventional generation resources. Again, these could be kind of thought of as your typical diesel backup generators that you might have, and also supplementing those with those renewable energy assets that we've invested in, and making sure that to the extent possible, we're able to offset the fuel consumption for those conventional generation assets with our renewable energy assets, while still maintaining a stable system during island operation, and making sure that we can run that system for as long as possible when we don't know how long the grid may not be available to us. So in this scenario, we'll take a look at that intentional island capability that Wave can bring to your microgrid. It allows you to do planned island transitions, do smooth transitions when you do have information of when there might be instability in the grid, or it's just in your best interest to be able to operate on your own in the weak grid scenario. To show that capability. And then once we're islanded, we'll be taking advantage of those renewable energy as it becomes available and backing off our conventional generation. So Don, maybe we can switch over and take a look at that if you're ready. Excellent, thank you. Okay, so right now, we're still in our grid connected state. We have made those conventional generation assets available. So they've switched from that local mode to remote. We haven't started them yet because we're grid connected. There's no reason for them to be online. We've backed our renewable profile back to 0 for the time being, just to show more clearly how the system's reacting to the changes that we're going to introduce. So again, that primary load is online, being fed by the grid. And so now we're going to go to our system control, and we're going to use what's called the PQ balance control. So in preparation for island, we're going to make sure the island control is running and ready for us to make that transition. What that'll do, it will basically bring on those conventional generation resources. So when we do make the transition, we have a frequency and voltage master that'll maintain a stable island for us. And so when we start that PQ balance, that's going to look at the active and reactive power flow across the PCC. So we'll go ahead and initiate that action now. And we'll start ramping up that conventional generation to meet the load of the system, reducing our consumption from the grid. And once that consumption from the grid is 0, then we'll open that grid breaker up and we'll be operating in an island state. So there you go. You can see, brought up the generators, open the breakers. So now we're operating in an island mode. So now as renewable energy becomes available, so right now we're running purely on conventional generation, but as renewable energy becomes available, we'll ramp up those PV profiles, start producing some energy from our PV inverters. Those will start feeding the load. And as a preferred resource, the lowest carbon resource available to us, we'll start backing off the conventional generation as that renewable energy ramps up. And if sufficient renewable energy is available, we'll even shut down one of the excess gens. Now, in this scenario, we still need to have a resource online that's going to be our frequency and voltage master. So we'll be keeping one of those generators online for now, since PV inverters aren't going to be able to provide that service for us. But we will make best use of that within the operational constraints of the generators. So we'll want to make sure that we're maintaining the minimum gen loading, operating the generator at its most efficient point, so that even though it is a conventional resource, it's at its lowest carbon output possible, while allowing us to make best use of our renewables. So there we see the second gen's offline. We're feeding the load primarily from the PV, but maintaining that stable island.